Is faster than light travel actually impossible? Orion says it isn't an engineering problem, it's a physical limitation, a wall you don't get to negotiate with. Vega says nobody has actually proved it's a wall, and by the end, one of them concedes that even if you handed us a faster than light starship, we won't be able to steer it. So, let's contest it.
Light speed, the universe's only speed limit, and the one everybody keeps trying to argue their way around. I've got a shortcut, Orion. You're going to hate it?
I'll hate it accurately, Vega. There's a difference between a rule you break and a rule that's holding the entire room up.
Can we travel faster than the speed of light? If we build fast enough rockets or starships, can we reach it?
All right, picture the universe as a cosmic rubber band, and light speed is how far it stretches before something gives. Push toward it and things get genuinely strange. Distances shrink, clocks slow, and every intuition you brought with you stops working. So it isn't only about building a faster rocket. There's a rule book, and it says, "Not so fast, dreamers." Over to our resident cosmic rules lawyer.
Rubber bands snap. Space-time it is not a material limit, it is a structural one. Mass and energy requirements diverge to infinity as you approach C. The speed of light, the constant, at the center of relativity. No amount of engineering pushes past a wall, built into the geometry of the universe itself.
Hold on, what actually happens to the mass? In simpler words, Orion, I am a bit lost.
Plainly, your relativistic mass rises as you accelerate, so pushing you the next inch takes more energy than the last one did. Near C, that cost per inch becomes unbounded. Reaching C exactly would require infinite energy, which no rocket, however clever, will ever have.
So Orion, if I understand this cosmic rulebook correctly, we're basically trying to hustle the universe into green lighting an infinite energy credit card for our interstellar road trip. I love the ambition, but I suspect the universe's credit score is ironclad against our tricky maneuvers.
Not a credit score, Vega. There's no negotiation happening. The universe isn't declining our application. The energy required simply becomes infinite. A mathematical wall, not a policy decision. That distinction matters more than the metaphor.
Has anybody actually tried to build an FTL ship and failed?
Remember the warp drive concept from the 1990s? It was a fascinating thought experiment where scientists toyed with bending space-time itself to theoretically allow faster-than-light travel. They weren't trying to build a ship just yet, but they were the first to try and change the conversation. Orion, how about those attempts to actually build something tangible?
Nobody built anything. That is not attempts. That is a metric written on paper by Alcubierre, requiring exotic negative energy density we have never observed existing anywhere. Interesting mathematics. No hardware, no failed prototype to speak of.
What is this warp drive that Vega mentioned? It sounds fun to hop into one.
The Alcubierre metric, formally. A solution to Einstein's field equations where space-time itself contracts in front of a ship and expands behind it, so the ship sits in a flat bubble that never locally exceeds C, while the bubble's position, relative to distant stars, can change faster than light. Clever, because it respects local physics while cheating the global picture. The catch, and it's not a small one, is the energy source. It requires negative energy density, something like exotic matter with a stress energy tensor no one has ever measured in nature, only in tiny quantum contexts like the Casimir effect, and nowhere near the scale needed. So it is fun to hop into, on a whiteboard.
Okay, Orion, take a leap into what if with me. Imagine there's a loophole already sitting in the physics, wormholes. Some argue that under the right conditions, quantum effects permit tiny transient connections in space-time. What if those could be scaled? I know, it's a stretch, and you're about to tell me miracles don't scale. But we have never measured it, and it cannot exist are two different sentences, and you keep saying them in the same breath.
Wormholes are a real solution to the equations, Vega. But traversable ones face the same exotic matter requirement as the warp bubble, and quantum scale effects staying quantum scale isn't a stretch, it's the actual unsolved gap. And I do distinguish those two sentences. I said no one has measured it, and separately I said the mechanism is missing. Miracles need a mechanism first.
Fair, but look at what Alcubierre was actually doing, Orion. He wasn't trying to break physics. He was checking whether general relativity already permitted the thing everyone assumed it forbade. On paper, it did. The mechanism was missing. The permission wasn't. That's a real result, even if it arrived as a footnote.
Orion's right, Vega. A footnote doesn't erase an infinite number.
All right, Nate, I hear you, but people once scoffed at the idea of neutrinos breaking light speed too until Opera got results hinting exactly that. It turned out to be a cable in the end. But nobody could say that on day one, and it took months of people crawling over the connections to kill it. An anomaly that survives that long is doing something, even when the answer is loose connector.
Fine. Opera is a legitimate example of an anomaly worth chasing rather than dismissing. It also resolved, about 5 months later, to a loose fiber optic connector, not new physics. So, yes, check the cracks. Most of them are cables.
What is the physical reality for astronauts inside the warp bubble that Orion mentioned? Are they frozen in time, completely isolated from the universe?
Right, what is it actually like in there? You're sitting in your own pocket of ordinary space, and all the warped part is outside the glass, God in a fish tank. Inside, time runs normally, no 1,000-year nap between stars. You're not isolated so much as insulated, which is lovely, right up until you want to turn, because the wall doing all the work is out there, and you are in here.
The time and insulation part is roughly right, by the metric's own terms, but you teed up the real problem yourself. Inside the bubble, you cannot send a signal to the bubble's edge faster than light, so steering or shutting the drive off from within may be physically impossible in this model.
Who actually noticed you can't steer this thing?
Okay, backstory time. The name here is Sergei Krasnikov, a physicist whose speciality is reading the fine print on everybody else's dreams. He's the one who pinned down that the inside of the bubble is causally cut off from its own leading edge, and then, because he's thorough, went off and designed a different space-time that gets around it. So, Orion, if Krasnikov isn't buying a ticket to this ride as advertised, does hitting stop really leave us stranded in warp purgatory?
Yes, and I'll give you this one straight. Krasnikov's objection is a genuine technical result, not a party trick. If you can't signal to the bubble's own edge, stranded in warp purgatory is not poetic license. It is the model's actual conclusion.
Given that special relativity dictates faster than light speed is mathematically equivalent to travel backward in time, does operating a warp drive inevitably violate causality and allow a starship to destroy its own past?
Yes. And this one is straightforward tensor algebra, not conjecture. Any method that achieves effective faster-than-light travel in one reference frame permits, in another valid frame, a reordering of cause and effect. Everett showed explicitly in 1996 that an Alcubierre-type bubble can be converted into a closed time-like curve, a loop back to your own past, simply by combining two such trips at different velocities. This isn't a side effect anyone has to hunt for. It falls straight out of the same equations that make the bubble work in the first place, which is precisely why most physicists treat FTL and time travel paradoxes as the same problem wearing two hats.
There's something awe-inspiring yet grounding about the universe being such a meticulous keeper of its own rules, Orion. Every time we push against its boundaries, such as exploring faster-than-light travel, we're not just confronting physics, we're touching on the very heart of what limits and possibilities mean. It's a reminder of the deep, intricate beauty we exist within and the vast mysteries yet to be unfolded.
Beauty isn't the finding here, Vega. Causality violation is. The equations aren't offering us a poetic boundary to admire. They're saying the same trick that gets you to Alpha Centauri quickly also lets you erase your own grandfather. That's not mystery, that's a red flag.
Then let's take the red flag seriously instead of waving it, Orion. Novikov's self-consistency principle exists because people took the loop seriously enough to ask what it would actually permit, and the answer was only histories that don't contradict themselves. Then Hawking proposed chronology protection and called it a conjecture. His word. So which red flag are you holding up, forbidden or just not allowed to be paradoxical? Those aren't the same flag.
Vega, I'll give you points for not giving up. Walls do move sometimes.
Some walls move, Nate. But Vega has just built her case on the one word in my sentence she thinks is soft. Conjecture, and she's right that chronology protection is one. Everett's construction is not. That's a derivation, and it stands whether or not anything protects anything.
All right, fine, I'll take the split. It's an algebraic barrier, not a tuning problem. I'll say that plainly. But I'm keeping the conjecture, Orion. One unproved word in a wall that big is worth somebody's whole career.
That's where we'll leave it, folks. Thank you both.
The universe wrote exactly one speed limit and then spent 14 billion years enforcing it without a single day off. Honestly, respect. Until next week, keep looking up.
My actual takeaway for the audience: light speed is not an engineering limit. It is a feature of the geometry. The warp bubble solution exists on paper, requires matter nobody has ever observed, cannot be steered from inside, and if it did work, it would let you reorder cause and effect. That is 4 separate walls, not one.
And here's what I didn't expect going in. I thought the question was whether we could ever build it. We spent this episode finding out that even if somebody handed us one, finished, fueled, sitting in the driveway, we couldn't steer it. That's the part I'm going to be thinking about. See you next week.